Okay, we're going to learn about another way to solve a system of equations. So, that's been our focus as of late. Systems of equation. Okay, so we have three methods. We've been learning to solve it graphically, right, with substitution. And this last one is called linear combinations. Or it's also called the elimination method, but it's useful when you see two equations in standard form. And same exact idea. For all of these, you can either have 0, 1, or infinitely many, okay? Solutions. Same idea holds. So let's go through some examples. Let's change it to this, and then 1 second. Alright. So let's use 2x plus, we're going to start off really basic, plus 3y equals 1, negative 2x plus 6y equals, let's make it 8. So the idea is you want to add it so you're only left with one variable. Add the two equations, that is. So you basically want to add these two together. Let's see, that's not working like I want it to work. There we go. We want to add these two together. Okay? So, let's do that. Let's add these two together. So, we can kind of put a plus right there. So, this one goes away, so we just get 3y plus 6y. Remember, these cancel out. We can kind of say they're 0 when we're adding it. Equals 9, okay? So 9y equals 9. So y equals 1. Now we have to solve for x. So at this step we can use either equation to find x. Let's use the first one. I don't want to deal with negatives. So we get 2x, right, plus 3 times 1 equals 1. So 2x plus 3 equals 1. We just got to do a little bit of work here. 2x equals negative 2. And we get x equals negative 1. So once you have it, don't forget to put it as an ordered pair. This is our answer, okay? This is a one solution case. Alright, now let's go over an example of one that has, let's go over another example. So let's make it chalkboard green. So we have 2x plus 4y equals 6, right? Negative 2x minus 4y equals negative 6. Let's see what happens when we add these together. Look what happens, guys. We actually, everything ends up canceling out. We just get 0 equals 0. So whenever that happens, it's the same line in disguise. So we say infinitely many solutions. Okay, infinitely many solutions. Let's go over one more. So 3x plus 2y equals 6. Negative 3x minus 2y equals 2. Let's see what happens when we do this. So we add these two together. We get 0 equals 6 plus 2 is 8. It makes absolutely no sense, so we say no solutions. Remember, this would be like two lines on a graph that never meet. Alright, let's go over some other examples. Okay, so let's make it a negative 2x plus, I keep using negative 2x. Let me use something else. Negative 4x plus 2y equals 2. 4x plus 6y equals 6. Okay? So again, we want to add these two together, like we put them together. So we get 8y equals 8, and we get y is 1. Now we got to substitute back again. Let's use this equation. So negative 4x, right, plus 2 times 1 is just 2, equals 2. We're almost there. Negative 4x equals 0. Right, so x equals 0. And then we have to put it together. So 0, comma 1 is our answer, okay? This is our answer right here. Keep on going, guys. Let's keep on going. So what if we have 3x, 3x minus 4y equals 1, and then 2x, right, plus 4y equals 4. Same idea here, except this time our y's are going to go away. We still add the equations. We still always add them, so we get 5x equals 5. Divide both sides by 5, as in the showing. So we get x equals 1. Now we can choose which equation to substitute in. I'm going to use this one. Right, so 3 times 1, I get minus 4y equals 1. Right, so 3 minus 4y equals 1. Subtract 3. Negative 4y equals negative 2. Divide by negative 4, divide by negative 4. I'm going to reduce this, y equals 1/2. So we have our answers, right? And you want to put it as a pair, so try to squeeze it in here. This is our answer, okay?